Well, what led me to be a structural engineer? I mean, I grew up building things with my hands, and I always built things, whether it's mechanical things or building things. So I had a bent for that, but grew up in a small town. I didn't know what a structural engineer was. Fortunately, I had some drafting classes in high school and stuff, and had some really good influences that said, hey, look, you might want to look at being a structural engineer because this is what they do. And you're good enough at the math and science. I didn't come at it from really good at math and science, so I need to be an engineer. I came from it, I want to build, and I was good enough at math and science. And so I tried it, and I'm like, wow, this is the best career ever. And sidebar, we just had a young student in our office yesterday who's a freshman in college, can't decide between architecture and engineering. We brought him in and we set him down with about 10 or 12 of our people. And it's amazing. We've got people from 73 to 24 in the office. And they all think they made the best career choice ever. And I think that's common in our profession. The people that are cut out for it wouldn't think about doing anything else. So that's probably the main thing, is it's just really rewarding. Thinking about the details, there's more than two, but there's really two things that determine the cost, the efficiency, and stability, serviceability, and longevity of a structure. It's material, the amount of materials, and it's the labor. One example is when I was working for a design build, design assist steel contractor, I was actually working on a Thornton Tomasetti project, and it was a long span convention center floor, and the floor loadings are very heavy. The spans are, I think it's 20 years ago, but I think it was 90 foot in one direction, 120 in the other direction. And to keep the sizes reasonable for the depth of structure that was allowed, we had continuity of these trusses through these large built-up columns. When you do that, you have to connect the top and bottom cord of those trusses to the column, take the forces through. And if you connect the top and the bottom cord, and then you pour the concrete floor slab on a 90 by 120 bay, just the dead load forces are huge. What we did is we sat down and said, well, what if we just connected the diagonal and the top cord and let the truss act as a simple span for dead load? Took 40% of the total load out of the connections. So the connections, which did have just order magnitude 3,000 kips, which is a lot of bolts, a lot of weld, took it down to somewhere around 2,000 kips, 1,800 kips. And that allowed us to pull erection time out of the project, erection labor, obviously, number of bolts, amount of weld, field time. Also pulled the connections in and made them smaller and less intrusive. And that's real optimization. We didn't change any member sizes. So Yankee Stadium, most people have seen it on TV. It's one of the larger baseball stadiums, and it's quite unique in its configuration. It's concrete superstructure up to a point, and it's structural steel above that for all of the articulation. Very long cantilevers for the suites and the seats. Leads to some really interesting connection configurations. So we start doing the analysis, we do the design of the members, and then we start looking at the connections. It's a baseball stadium and it's exposed, and these connections aren't all that pretty, and they're very large. So the next thing we look at is very very expensive field welded connections, all field welded. We're like, God, that's going to kill the schedule. We're in New York City. You know, the labor laws, the confinement that you have on a job site. It was just going to kill the schedule. So we looked at, okay, what do we do to emulate the all welded connection as close as we can and get the field efficiency of the conventional gusset plate connections. So we sit down and said, well, which member's primary and which member's secondary, what's the force flow? And so we went back to basics. We actually went back into, as connection design, we went back into the analytical model and traced the forces through and decided which ones we could kind of pull out of the main connection. We basically emulated the all welded connection and followed just the primary load path, and the secondary elements connected kind of outside of that connection. Made it very compact, and the architect was able to leave several of them exposed that he would have otherwise had to conceal because they're just kind of industrial.